It was just 11 o'clock, 11 minutes and 11 seconds. I think it's a sign from whatever's up there above. Thank you for taking the time out of your obviously very busy schedules to be here with me today. I'm going to do my utmost to make it worth your while. It's a fun one. It's a bit of a side quest for me. This is not my core business, not my core topic, but I happen to use it in my everyday life. And I won't say I fell in love with it. It's a bit strong emotions there, but I kind of liked it. And I would like to take you on a journey. Maybe you like it as well. I mean, there's a lot of more people. Come in. This is just the warm-up. We're not doing actual content yet. We're just checking the vibe of the room and making sure everyone's on the same page here. So it's a bit of a side quest for me. Load testing, it's always been one of those subjects, and everyone has his own opinion and their own technology. And I happen to like the K6 one that we're going to talk about. Just for reference, I'm really happy to be here. Thanks, Sven, and the crew for inviting me here. It's a change of pace of speaking in Belgium again. I usually speak abroad. And despite the fact that I'll be doing this in English, I still want to say hi in Dutch. Hallo iedereen. Hallo aan alle mensen die Nederlands spreken. Het is leuk om nog eens in Gent te zijn. And that is that. So, hello, folks. My name is Thijs. And yeah, let's kick this show off. I'm the technical evangelist at a company called Varnish Software. Now, Varnish Software, who's heard of that company before? I mean, who's heard of Varnish Cache before? Probably, right? It's a first-class citizen within Drupal, I may say. It's the caching technology we hopefully all love. And it's used by quite a lot of websites. And while this is not a Varnish talk, there is a context and there is a relation to what we do on a day-to-day basis. So that Varnish open source project, that cache, along with the enterprise product that I also push, is used by about 10 million active websites. A lot of them need acceleration. A lot of Drupal sites in there as well, I guess. 22% of the top 10,000 websites are using this. So if you ask me what I do on a day-to-day basis and what the company does that I work for, the answer is we try to make the web faster. That's one thing. What we also try to do is enhance digital experiences by lowering latency, which is another term and more of a soft and fancy term for saying that we also use these acceleration tools to build content delivery network, software-defined private content delivery. So we are a company that builds software-defined web acceleration and content delivery solutions. And our claim to fame, I love throwing this one around, because this was a benchmark that was done by Intel and not by us. And their conclusion was that our software can handle 1.3 terabits per second on a single machine, which is kind of fun. You may ask yourself the question, who needs this? Who in this room would need 1.3 terabits per second? Yes, yeah, I thought so. Well, as it happens, the wonderful world of the web and HTTP goes way beyond websites. Like, we are here in a web context at this event, in this setting. But a lot of our clients built HTTP streaming platforms, and it's very easy to reach a terabit per second. And like, I'm talking today at a Drupal event. On Tuesday, I'm in Cologne speaking about this number, this very number here, that 1.17 gigabits per second per watt. Efficiency level, sustainability, you name it. So that's the world we live in, and I'm going to marry it to the topic that I'll be talking about in just a minute. Just want to say that I'm available on social media if you want to reach me afterwards, if you have questions, or if you want to heckle me. That's also pretty good stuff. Mind you, I still use the old bird. No X's in my presentation. The author of getting started with Varnish Cache, Varnish 6 by example, not really relevant in this topic. Usually I bring free copies of the book, but I'll be speaking about load testing. And the context to what I do on a day-to-day is, okay, you talk about web acceleration, about caching, about content delivery. You put it in place. You make certain promises and assurances that it will work fast. But how do you actually measure it? And that's how this topic came about. This topic of load testing is actually checking out if you can give the system a run for its money and what your mileage is. And the practical way I got in touch with this technology is a world tour that my boss asked me to do back in 2022. So we had this really interesting enterprise-grade software that we wanted to show to the world. And I traveled literally around the world. I bought a around-the-world ticket. You can buy these things. You start in A, you pick a direction across the globe, and you come back and have a bunch of stops where we talked about the next-gen content delivery live world tour. But I needed something to show our software. And it was, what is out there? What can we use in terms of testing software? And all of a sudden, this colleague of mine came up to me and said, why don't we use K6? It's like, all right, K6, pitch it to me. What is it about? Well, it's this wonderful open source tool built by the folks at Grafana Labs. And it has certain capabilities. Capabilities like the fact that it comes under the form of a CLI tool, a very powerful CLI tool. It allows scripting in JavaScript, which is kind of nice. And it has modules. You can extend the behavior. You can write complex scenarios. And you have measurement elements in there, like a check, like a threshold, like a metric. And don't worry, we will get to all of that. We'll show you the nitty-gritty of all of it. You can customize the entire way of things being executed. There is a test builder, a browser recorder. And that's where we get to, if we can fast forward near the end of the presentation, we'll talk about result storage and visualization integrations in tools that you might already use. So for me, the thing that caught me in a good way was, hey, you can write your tests in JavaScript. Now, I'm by no means an expert in JavaScript. Is JavaScript my favorite language? Hell no. However, it's the language that a lot of people use. And that's why I find this such an enticing and powerful feature, because it lowers the barrier of entry quite dramatically. Point in case, or case in point, what is it? As a matter of fact, this is the most simple of tests. You import an HTTP namespace from K6 HTTP. You have this standard function called the default function that is exported. You do HTTP get, and that's how you do the most basic of load tests. So does this make sense to anyone? Who's semi-fluent in JavaScript here? Semi. Like, who can do an alert and a console log that's semi-fluent? See, that should make sense to you, right? This is not that out of this world. Now, how can you run this? Once you have that script lined up, or a more complicated version of that, how do you go about your business of running it and seeing how it performs? Well, there's 3 different incarnations. We have the local one, open source, using command line tools, kind of fun. We'll be focusing on that quite a bit. They have a commercial product as well that I've never tried out. Apparently, it's nice. It runs by the same CLI, but it sends the metrics to the cloud. Great, I guess, but I have no experience with that. And there's a Kubernetes version of that as well, also open source, that allows you to orchestrate it and do the distributed nature in an automated way, rather than doing it more or less manual, as I'm going to do. So here's the simple way. K6 run. This is written in Go. You can install it through a variety of ways. It's just a binary. K6 run and the script that you've just defined. And that is it. If you want to run it in the cloud, then it's K6 Cloud, of course. And if you want to do Kubernetes, of course, it's going to be a lot more complicated than doing it in a very simple way. You have to set up some custom resources and have to do kubectl apply, and it will run on that cluster you have defined. This is what we're going to do. We're going to focus on local execution without really discarding the distributed nature of it. We'll get to that eventually, but before we can do, we need to establish a baseline, build up some knowledge, and then we'll use that knowledge that we've gathered here today to do some fun stuff. So when you run the script, when you need some output, and this is the typical end of test results that is produced by K6. Kind of nice. I'll zoom in a bit to the more valuable information. You can see data received, data sent, all kinds of HTTP timers, from how long did it take to connect, maybe the TLS handshaking, the time to first byte, which is the waiting. You see averages, medians, a lot of information. Kind of cool. So we've reached the point where we know what K6 is. We can write the simplest of tests. We can run it. We can see the output. You already have something to work with. But of course, doing a simple call to, well, like if you look at these numbers, like how many iterations did we do? It's pretty pathetic. We did a single iteration, a single HTTP request. We can't really qualify this as a proper load test. So we need to scale that stuff up. And there's multiple ways of doing it. The easiest way is just by specifying a duration with -d and using -u to set the number of virtual users. So all of a sudden, we're testing for a duration of a minute. 100 virtual users will be spawned from that single installation we have on that single server. We can also do it in a more portable way so that you don't depend on command line parameters. You have this options data structure in which you can specify the number of virtual users and the number of durations. And the variable in this case is the amount of times this HTTP get gets executed. And that's where we get to this nice little triangle. I'm not an expert in this matter, but from what I've heard, it's the CAP theorem. You can choose 2 out of 3. So you can choose the number of iterations you'll do and the time it will run. And the end result, the variable, will be, hey, the virtual users will be variable and depending on the scenario. If you choose, or if you set the virtual users maybe to 100 and the time to a minute, or an hour, well, the amount of iterations that will come out of it, the amount of times this default function will be run will be variable. So only 2 out of 3 can be chosen. And we'll talk about the various scenarios near the end. The first thing we're going to do now is dig a bit deeper on the HTTP side of things so that you understand how you can trigger or write scenarios that do a variety of HTTP-related things, because that's the context, right? HTTP. We're at a Drupal event, so it will be primarily Drupal, but it could be just websites, could be APIs, could be other stuff. There's even a browser testing feature in it that I won't cover that allows you to really integrate with the hypermedia and the HTML. So HTTP GET, we know this. It's not that spectacular. It's not that difficult. We can use an interpolation syntax with backticks and do some looping and throw in some variables. There's a ton of documentation out there of information and libraries and capabilities that are available. But you can start fiddling about with a params data structure that says which cookies you have, headers. I'm not saying anything too spectacular, right? You folks know this. You know how that works. You can have a bunch of request parameters like the cookies. But if you do multiple requests, you can keep track of cookie states with a cookie jar where you store the cookies, headers, authentication, redirects, tags, all that kind of stuff, all those nice things. You can also do posts if you want to test maybe a form submission or API calls. Again, nothing too spectacular. Regular data with just form style data. If you want to do it in JSON, you can use another library, JSON Stringify, to do JSON-based API tests. Again, very run-of-the-mill, very straightforward. And as a matter of fact, this is the API of the method calls you could do. Get, head, post, delete, patch, put. Very much in the territory of RESTful APIs and websites to some extent. You can also do options. There's even an abstract request method here where you can specify the method. And you can batch these together and do multiple ones at the same time, as you can see here. So it will open up various TCP connections. We'll send those in parallel. And you can bunch them up, batch them up in different ways. You can do it with objects. This is the array style of doing it. And here's a little nugget of new information that we haven't talked about. So all of a sudden, this output comes there, and I am doing a check on it. So it's time to transition from just doing regular HTTP stuff to actually checking what is going on. And a check, as the name indicates, well, it checks the output and matches it to certain assertions, as you can see here. So we've isolated the example to a very simple thing. You do an HTTP GET, and we expect the response status code to be 200. You have a name for it and an assertion, and this, that, and the other. This is the API of doing it. Val, sets, and tags. So what it does is, and that's the confusing bit that I had to spend some time wrapping my head around, when a false assertion happens, it doesn't stop the execution. It doesn't mean because the check has failed that your test stops. Rather than doing that, it does something more interesting. It keeps track of that decision and starts measuring that at a rate, like how many failures did we capture. Doesn't mean we stop, we just keep track of the failures. And a failure is not just a 500 error in our case, that is something that wasn't a 200. So it was a 201 or 301 or 302, it doesn't matter, it failed that. And then it can keep track of it. You can do other stuff as well, check whether HTTP2 was used or any other metric available. You can batch them up in a selection of checks. And here's the output for that. And I'm going to do you a favor, maybe zoom in a bit. So this is where the check succeeded. It was 200, life is good, all is as supposed to be. And there's a checks property or a metric on top that is at 100% because, as you can see, 1 succeeded, 0 failed. If it does fail, then it keeps track of it. And the checks is at 0% because maybe it was a 404. If you do want to stop the execution when certain criteria aren't met, then it's not really checks that you need, it's thresholds that you need. Thresholds are the thing that will stop execution if a certain criteria are met. Example, we want to ensure that the requests failed, the failure rate stays below 1%. Or that the request duration and the 95th percentile of that stays below 200 milliseconds. Those are criteria you set up. You register them, again, in that infamous options data structure. And as it runs, things will happen. And nothing is wrong. Everything acts accordingly. You can see it. The check marks are put next to the 2 things we measure in terms of thresholding. And when it does fail, let's say we lower it from 200 milliseconds to 90 milliseconds as the 95th percentile of request durations, then you will see this. Again, let's zoom in. The thing that failed has a red X next to it, and then it stops the execution immediately. So whether you want to do that or not, that's your decision on whether to use checks or thresholds. Now, the screen isn't wide enough, of course, so I'm going to move it a bit. As you can see here, you can also see what caused that. So we expected it initially to be below 200 milliseconds. It was 100, an odd 100, 100.79. When we lowered that to 90, of course, it didn't meet the criteria, and that is what we see. Now, we can bunch these up as much as you want. You can say, we'll do a collection, so 90th percentile below 400, 95th below 800, and so on and so forth. You can define multiple thresholds, multiple metrics. You have the freedom to do it. It's just the API there. You can write however you want it. Next topic, tagging. Tagging's pretty interesting. I've learned something new about tagging 3 weeks ago. I'll share it with you. I've been doing this presentation for more than a year and a half now, and then every now and then you have this little nugget of information that broadens your horizons. So what is it? It's a way to categorize all those properties and data structures we have, such as a check, a threshold, a metric, or even a simple HTTP request. There are some system tags built in that are associated with all these properties and that you can extract. The statuses, the protocols, checks, error codes, you know how that works. And you can use it within your JavaScript code. So for an individual HTTP request, you can specify a tag with location of this test case is in the EU. Reason why I'm using location is because in my testing setup for that CDN that we built, that private CDN, we did load tests from different regions. So I had a bunch of servers in Singapore, a bunch of them in Ireland, and a bunch of them in the United States. And to ensure that we knew where these requests came from, we applied some tags. Very specifically on that HTTP request, but we can do it at a global scale. If all the HTTP requests in this test should be categorized in the same way, well, then your tag can be mentioned one level up. What I like particularly, if we want to keep the script the same and want to inject some external context, is maybe use a tag parameter at the runtime level and inject whatever you have. So I can use that script.js in all my sites, all the different locations, without having to specify anything specific in regards to EU, US, Asia Pacific. No, it's just the runtime parameter that you alter, and the script remains the same. So here's a small piece of script that I've built. We do it in the setup. We'll talk about the different stages of execution, but setup, maybe a little bit of spoiler ahead of time, is that function that it's called once to set up the entire setup, and then it's being consumed for the duration of the tests. So I use that exec vu tags property and extract the location tag, which was injected at the command line level, which you saw in the previous slide. And then we match it to specific locations. And as we return it in this data structure, it is being dependency injected into the runtime, so we can use it. So we can actually start calling in different endpoints based on information that was being injected. I'm doing this based on tags because it's categorized. You can use environment variables or other structures to start externally pushing in dependencies, information, state. You can also use those tags, interestingly enough, to do thresholds. You can say everything that is tagged with location EU, we're being a bit more lenient in terms of performance expectations. We want those in the 95th percentile to respond within 400 milliseconds. And if your tag is the US, well, it has to be faster. We'll do 200 milliseconds. So a lot of flexibility there, a lot of capabilities there. I use these tags, and again, this is a big spoiler to what we're going to talk about. There is a Prometheus way of delivering output. And if I want a specific label to be available for me for my Prometheus queries or visualization in Grafana, I can define custom tags in there in my script, and I know there'll be labels later on. So I can do some string parsing or information that I want in there, and I can use it. And that's why tags are so useful. We also have groups. Groups, as the name implies, groups, logic that is closely tied into each other. So if we quickly do a fast forward, so we have a group called get and a group called post. You probably can guess what's happening within each group. All the get requests are stored there. All the post requests are stored there. And the cool thing is that a group name is also added as a tag. So this is a way of like bunching up code that is related to one another and adding a tag. So if you look at the output, and again, let's zoom, you have your get group and then all the checks that are associated or all the thresholds that are associated with, and the same for the post. So in terms of visualizing output, using groups, if there's quite a bunch of things you need to do, is quite convenient. All right, those are the base primitives that we use within the context of this presentation, within the context of K6. Let's talk about the test lifecycle so that you know when things happen. Because you've seen a variety of functions already. You have that data structure, the options data structure, the default function, setup. What is all this about? Well, here it is in very abstract terms. I added the comments for context. So everything you define outside of the scope of these functions is initialization code. It gets called once per VU. A VU is a virtual user. So that means if you have 100 virtual users, all the code outside of the scope will be run 100 times. The setup function, as the name implies, is called only once. It's your bootstrap for the entire test case. Whatever happens within the default function, and that's where the HTTP GET goes, typically gets run once per iteration, because a virtual user can run multiple times, so multiple iterations. So if you have 100 virtual users and you do 10 iterations, that stuff is going to be called 1,000 times. And then, of course, we have the teardown, which is called only once. So going from abstract to practical, if we try throwing code in there, this is how it works. Maybe a side note, maybe you weren't aware of that, all these endpoints, these HTTP endpoints that you see there, are real and are gracefully provided by the people at K6, at Grafana Labs. So all these scripts you see, you can actually run them and see it for yourself. Some of them might be a little bit off, a bit weird, but it's for the sake of it. Like if you look at the setup function, what I'm doing is basing all my tests on external input that I pulled in via HTTP. So I'm going to that JSON endpoint that K6 offers. I'm doing it once within that function, and I'm checking a data structure. Because it's JSON, I parse it to JSON, which is called slideshow, and it has slides. And these are my slides that I inject into my actual tests. So when we go here into the nitty-gritty of things, we iterate over all those slides, and we do an HTTP call, see how they respond. So this is an example of mixing up an HTTP call, not for testing purposes, but for setup purposes, and then using the results with actual tests. So tons of flexibility. And I had to find a way of doing teardown code. Like, why do you do teardown code in HTTP? Like if you would access files, you would close the file. Or if you have a network connection that would remain open, you close it. But what do you do for this? Well, you use console.log to just say anything. All right, we're 20 minutes in. Let's take it up a notch and talk about the metrics that we've seen so far in the end of tests and try to access them ourselves. So what you could do in the result, when you get the result back from your HTTP call, you can start inspecting it. And you can do a console log and say, what was the duration? How many milliseconds did it take? And actually use those values in your script to do other things. Because regardless of the structure, so if we remember, we have virtual users running the default function. Within that default function, there's multiple iterations happening. That default function is going to be called time and again until the criteria are met. But within an iteration, you can do multiple HTTP calls as well. So you can measure whatever comes out of your first one and then make decisions based on that. Besides res.timings.duration, which is the full duration, there's a bunch of other timers. The blocking time, connection time, TLS handshaking, how much time it took to send the payload, how much time you had to wait, which is your time to first byte, in fact, and so on and so forth. Pretty cool, pretty useful. But what if I told you you can actually design your own metrics and start measuring the things that you care about that may be completely different from this? And that's where custom metrics come in. And it's pretty nice, I must admit, and I've used it before. So you can start defining your own counters. So the context, long story short, about this slide, we're going to measure the ranges of HTTP responses. I want to measure how many 200 style, 300 style, 400 style, and 500 style metrics were the result of my HTTP calls. So I'm setting them up as the counters, and I'm going to do some randomization. That's why we have this statuses data structure with 200, 300, 400, 500, because it's a bit fake. And we do 20 iterations, and we get a random status code. And if you go to this endpoint here, again, provided by the people at K6, they will return the status code you asked it to return. So it's very synthetic. But it does the job, and it shows you that if the response status is between 200 and 300, you increase the counter. And then that way, all of a sudden, if you look at the results, you can know that from all these calls, there were, what was it, 6 200s, 4 300s, and so on and so forth. That's just an example. Another example I applied was I had this video streaming platform using HLS HTTP-based video streaming, and I wanted to capture the resolution that was used. So whatever came out, I wanted to know if is it 720p, is it 1080p, is it 4K? Well, I designed my own counters. A counter, as you may be aware of, is a number that continuously increases. It's, as it was nicely put here, the cumulative sum of values. But there's more than counters. Counters only increase. What if you want the current value? That's where a gauge comes into play. Gauges can also be custom defined, and a lot of these metrics that you've seen before are gauges. They collect the last value, but also keeps track of the minimum and the maximum value, and you can use that. A rate is as literally defined here, a percentage of non-zero values. So whatever returns true or 1 or whatever is counted as a plus, and whatever is 0 or false or anything else is counted as a negative, and the rate counts the non-zero values. And then you've seen the trend before. We've talked about it with thresholds. We're talking about 95th percentiles and minimums, averages, all that kind of stuff. And that is used in the end of test metrics. So when you look at them, well, you know all of these. What you see here, the top one, data received, that is probably a counter because it increases. This one, rec blocked, well, that kind of looks like, and I've lost my train of thought, a trend is the word I was looking for. So you probably know what these look like. You've seen them, the standard ones, you've defined your custom ones, but you can also manipulate what you see at end of test results. By doing this, again, in that very infamous options data structure, by saying, whatever we see, the summary, I only care about average, min, max, and count. And all of a sudden, boom, the output starts to minimize. You only see what you want to see. And you can do that at the command line level as well. Well, the trend stats, I want to see average, min, and max. Or I don't want to see any summary at all. Imagine. So you're doing tests, you're running them, and in the end, you don't care about the output. We'll get there. There's real use cases for that. Whatever you get is nicely presented if we go back in this diagram, right? We've seen it before, and the ASCII art and all the bells and whistles. But you could also say, I want this in JSON. So write it to a file or in a CSV file or whatever you want. Because maybe at the end you want to parse it. But let's get to the use case where you don't want to see end of test results, where you don't care about what's being output. Because let's face it, when you run these tests, at the end of the test, you see the results. But maybe you want some real-time metrics. And this is where we're going to spice things up a bit. This is where things are going to get more interesting. Maybe that test runs for an hour, and you want to see every single second or every 10 seconds how the test is behaving. That's where real-time metrics come into play. And this is where K6 starts harnessing more of its power. It has a bunch of integrations in how to store the results. You probably know a bunch of them. There's some time series databases in there, some cloud systems in there, some SaaS products. I tend to like Prometheus. Who is familiar with Prometheus here? By show of hands. That is surprisingly little. Surprising. Can I say to those, because I don't want to insult anyone here or speak in the wrong way, can we say that Prometheus is somewhat of a standard in our world of how to display metrics? Am I saying, do we agree on this? Yeah. Not everyone is as excited, but let's put it that way. Prometheus is a tool that is used by a lot of people to visualize statistics in a preset format. And I'll show you that format later on. In order to have Prometheus output, there is a Prometheus module within K6 that allows you to do API calls to a Prometheus server and send the results there. I don't like that way of working because it poses scalability issues. I've done tests at large scale. I did one last month where we sent over 500 gigabits per second over 4 servers. And if it has to call back to send the results every single time, if you scale that up to thousands of users, your Prometheus needs to be able to scale along with the scale of the tests. And that's not really feasible for me. I don't like that way of doing it. I would rather have my Prometheus server, and that's the basic way of how it works, to scrape my K6 and say, hey, give me the stats. And 15 seconds later, give me the stats. And that's how you do it. In order to make that happen, you need a custom binary, a custom install of K6, which is not that hard to come by, to be honest. You can do go install xk6, and xk6 is a tool to build K6 binaries. And then you build it with that Skibus Prometheus method. Works pretty well. And then the output is a custom K6 binary with extra capabilities. And the only thing you need to do is specify -O for output and say Prometheus. It will be available in a specific namespace called K6 and available on port 9090. So when you run this, port 9090 will be available within K6. And then you can do a curl if you're on the same system, local host, and get these real-time statistics. And that's what Prometheus output looks like. It's very popular. It's definitely a first-class citizen within the Grafana way of displaying statistics. And it has the quantiles, and it has all the bells and whistles, everything you need. And that's where we start using Grafana to visualize the results of our tests in real time as the test is being executed. That makes it a lot of fun. And that then, and this is where we get into the world of distributed load testing, because I don't want to cheat you out of this. This is a distributed load testing talk. This is how we do it. You can do it in Kubernetes, obviously, but you can start running these in different locations on different machines, and then have your Prometheus config scrape those in the different regions where you are and aggregate all those statistics in a single database. And then you can start doing differences, like what was the latency like from the US? What was the latency like from Germany, for example? And you can start making really interesting analysis and visualizing them. You can define labels and say, I am interested in the statistics coming from Ireland in terms of request duration at the 50th percentile or at the 90th percentile. And that harnesses a lot of power and gives you the ability to see things like this. This is a screenshot of the test I run. So as you can see, there's 300 virtual users, 100 from Ireland, 100 from Singapore, and 100 from the United States. Top left corner, you can see the request rate, no failures. What you can see then is that we're doing mostly sub-millisecond latency. This is where it connects back to my everyday life. I wanted to prove that Varnish as a technology doesn't really add latency. This is a bit synthetic because the load testing tools, the K6 servers, are in the same AWS data center as the receiving edge nodes. So you're on their backbone, there's hardly any latency. You're not going to see this in the real world. Like, good luck getting 0.7 milliseconds of latency on any type of website. I think in the context of where we are here, the Drupal world, isn't 200 milliseconds what Google expects for good SEO, right? Is it 200? If we stay below, I think everything below 60 or 50 to the human brain is considered real time. So we're in exotic territory. This is not really normal. But it does show you that we do pretty decent results. Ireland sends a gigabit, more than a gigabit, 1.89 gigabits per second. Singapore, 154. You can see nice trend stats, and you can do all the stuff you want. And these are some of the functions I used within the Prometheus context. So we did the number of HTTP requests at a rate interval, apply a rate function, sum them up, group them by country. It's a bit like a query language, as SQL is, but specifically for metrics. And all the metrics I could extract and visualize. And actually do distributed tests. So we can do fun stuff. We can make Grafana listen on port 6565. It typically listens on 6565. I want to highlight that. So when you run Grafana, not only are we available on port 9090 to extract metrics, we're available on port 6565 to control the execution flow. Because good luck trying to log into all those terminals to, let's say you have 100 load testing servers in different areas. Good luck having 100 terminals controlling all of them. Just spin them up, set them in pause state, make sure it's available on a port, make sure that port is open and available, maybe protected. Use, and we'll get to that all the way at the end, use an externally controlled executor so we can scale it as we see fit. And this is the end result. All these machines are spun up, they're in pause state, they have a script, they're available. And I can then do, hey, K6 resume -A, which server? Oh, Ireland.test.com. Boom, start, you get the output. Okay, let's do the same for Singapore. You're sitting in a single terminal. Maybe you can orchestrate this from a piece of code. You have to just say, start, start, start. Resume the test from the US, and start scaling it. We're interested, instead of 2 users, 100. Maybe scale it to 1,000, and you can do it ad hoc in a very distributed way. And I love that fact, and I use that quite often. I get to go to trade shows quite a bit where I need to, it's all business, right? I need to convince people that our tool is really good, and I always throw this one in. I was at a big trade show in Vegas a couple of weeks ago, and we sent over 500 gigs per second with 8 of these K6 servers spread across different regions, and then people actually see, okay, 500 gigs a second, that's no Mickey Mouse numbers. And we use this tool to do it without having to log in into all those windows. Now again, K6, as you run it as a server, we also have the K6 binary that you see here as a client to resume, to pause, to scale. But in fact, it's nothing more than a wrapper across an API call. So what you could do if you don't want to use that binary, you want to integrate it into your own code, you can just call that endpoint on 6565 and ask for its status. And it says, hey, life is good. I'm not in a pause state, and I'm doing tests at 100 VUs at the same time. And by the way, these tests are running. So you have an API call, and APIs don't just do get. You can do patch and start scaling it up to 500 users, and it will respond in JSON in the same way. You can get individual metrics via HTTP if you want to as well. So you're not forced into anything. There's tons of flexibility to do that. So that's quite cool. So now we've covered a lot of ground already, right? I initialized the context of K6 is, how it can be used, talked about the HTTP calls, all the primitives, checks, thresholds, what you want, right? How to manipulate end of test results, how to do real-time visualization of metrics. We've talked about controlling it, doing it in a distributed way. And the final part of the presentation is defining scenarios. You can do basic HTTP calls, test specific endpoints, but maybe you want to do some deeper digging and apply it in a more advanced way. And that's where certain scenario parameters come in, where you can control the iterations and the VUs and how long a test should take and when a test should start and what executor it should use. In terms of executor, we also have seen or already seen the external executor, allowing you to externally control the behavior. But in order to properly set the scenarios, we need to be reminded again of our little triangle here. In whatever you're going to see now, we're maybe going to set the VUs to a certain value and the iterations to a certain value, which makes the time the variable, and in all other directions, right? You get it, right? If you set VUs and time, iterations will differ. And here is a little example of that. So you can define scenarios, again, in that options data structure. And we're going to call it shared iter scenario, which is a shared iteration scenario. The executor is shared iterations, which means you have this blob, this bunch of work, and you're going to distribute it across all the VUs. How many of them? 10. How many iterations will we do? 100. So there's 100 iterations that will be shared across 10 users. You can also do it per VU and say, well, we have 10 iterations for every VU, and the end result will be the same, 100. But the way this is executed is slightly different, and your results may vary. These are a bunch of the executors that are available. I'm not going to cover all of them, but I am going to show you a couple more before we end the presentation. Now, of course, I was scheduled, right, Sven, for an hour. I will not need the full hour. We can fill it up with whatever we want, right? We can do some Q&A or have an earlier lunch break. Like get quicker access to, what is it, sandwiches we have? What is it? Proper lunch, quicker access to proper lunch. It's not a bad trade-off, right? But still, I'm not going to rush it. I am going to show how it works. So this is based on this is what we're going to base ourselves on. These are screenshots of the blog from K6, and I quite like it. So let's go back. This is the end result. This is what we're going to analyze. Shared iterations. We have 200 iterations that we're going to run across 10 virtual users. So you have that big block of work. You have these 10 virtual users standing next to one another and say, give me work, let's do it, let's do it. What happens here is the endpoint gets executed, gets measured, and then we sleep for half a second. We have to factor that in. Now, if you want to see that, what that looks like and how it behaves, this is it. The test is going to last 8 seconds. So if you think back about our little triangle here, we didn't set the time. We set the max duration. We set the timeout to 30 seconds. But we did lock in the VUs and the iteration. So the timing, what you see here, that 8-second duration is the variable. And the iteration rate, well, the VUs are fixed, but it ramps up to 20 iterations per second. That's the end result. If you look at it, it kind of makes sense, right? 20 iterations per second, more or less. But we can do the same thing at per VU iterations. Instead of saying, here's this amount of work you have to do, dig in, it's like, okay, here's the amount of work. We're going to pre-separate it and give you 10, and give you 10, and give you 10. 10 minutes left, nice. So then you see that the test takes a second longer. Why? And I already highlighted it. There's lower efficiency because of idling VUs. There might be VUs that take a bit more time, and there's others that are done a lot quicker. And when they're done, they're just sitting there waiting. They're not taking on extra work. So in that case, it took a second longer. Let's take it to the next level, a different part of the triangle. Let's fix the VUs at 10, constant VUs, and we're going to run for 30 seconds, which means the number of iterations is going to be variable. And this is what we're going to see. We're more or less aiming towards 20 iterations per second, and in total it will be 600 iterations across 30 seconds. But the VUs are fixed again. 10 VUs, 30 seconds of testing, and the iterations will vary. It all depends on what you need, right? You can take that to the next level and say, hey, let's ramp up these VUs. Let's set different scenarios. We're going to go from 0 to 10 virtual users in 20 seconds, and then we're going to go back to 0 in 10 seconds. And there's no gracefulness in there. It's just very abrupt. Build up, go down, last for 30 seconds. Pretty cool. Let's take it from an entirely different approach and say we want to have an arrival rate. And the arrival rate means that we're aiming for an iteration rate that is pretty stable. So that means for a duration of 30 seconds, we're going to try to do 30, we go at a rate of 30 executions within a second. And we're going to start with 2 VUs, and we can grow to a maximum of 50. So all of a sudden, the number of virtual users is no longer set. In the beginning, we either set it hard, or we created scenarios. First do this many, then do that many. Now it doesn't really matter. The only thing that matters is that we're at that iteration rate. Focus on iterations per second. So let's see if we can do the maths here. There's 30 of these actions happening every single second. That's how we express it. We can have 30 per hour, 30 per second. It doesn't really matter. But you see that the line of executions per second, iterations per second, is pretty flat. And then, of course, as a closing note, as the final thing I have to say is we have externally controlled. I shouldn't go any deeper on it because you've seen it. It allows you to not use scenarios to come to these outcomes of number of virtual users or iterations or timing. It's all done using the command line externally or via APIs as you see fit. So this is, ladies and gentlemen, the time where I say goodbye and thank you. I usually try to skip Q&A, usually. The reason is can do much more interesting things. 2, people are sometimes shy and don't want to ask real questions. And 3 is the people who ask questions often ask very personal questions that might not be relevant to the rest of the room. That's theory. We still have, what, 5 minutes? I was asked, because this is being streamed, if you have a question, I'm going to throw this. Let's try to do this in a careful way, and we'll see about that. If you don't want to ask questions now, but still want to have a chat with me, I will be available until after lunch, I guess. So that being said, thank you very much. But are there questions? Everyone wants lunch, right? Are we on the same page here? Okay. Thank you very much. It's been an absolute pleasure to be here back in Ghent. And as mentioned in the beginning, this is a side quest for me. This is not my primary presentation, but I enjoyed it, and I enjoyed your presence nonetheless.